Hi guys, thanks for joining. This is going to be Essence of Science. We're focusing on what is temperature and does it make you sick?
I'm Dr. Abbasi.
I'm Melissa Haber.
I'm Misha, yeah.
So, as you know, I'm a neurosurgeon, and part of any neurosurgical training is medical school, and part of any medical school, lots of science. Melissa, tell about your background and your connection to science.
Sure. I graduated from undergrad with a bachelor's degree in the science of biology and an associate's degree in chemistry. Then I went on to physician assistant school where I got my master's of science in physician's assistant studies.
Okay.
So that's my background with science.
Michelle.
So as for me, I went to college in North Carolina. I have a bachelor's of science in finance and a double major in statistics. And after that, I went to U Chicago to get my master's in data analytics, machine learning and stuff.
So I'm more focused on the human aspect, not as much the technological aspect, but I'm curious, and this is why we're doing the podcast. The temperatures are changing, and I'm wondering if you go outside with a jacket, will you get a cold?
This is actually not a easy question. Melissa, tell me, what is temperature? Can we wrap our head around what is temperature?
Well, I think the basic definition of temperature is, just the unit of measurement of which, the air quality, how you feel. There's different ways of measuring temperature based on units, but as a whole, I think you're onto something. The bigger picture of what is temperature, what causes fluctuations in temperature.
So certainly we feel temperature, but if there were on Mars where there is no human to feel any temperature, still have temperature.
Yep.
In the middle of the sun where there is no human to feel any temperature, there is a temperature. By the way, what's the temperature in the middle of the sun? About 40 million degrees Kelvin. Michelle, tell me about it. What do you think what the temperature is, and tell us about the units of the temperature and what they really mean. Maybe a little as a history, if you know, how they came to be.
Oh, well, I think this is bringing me back to middle school physics.
Oh, in China, that's a middle school physics? Good for you.
It's true. That's some high school, college stuff.
Temperature for me is like the speed at which the molecule bump into each other. So I think there's a maximum temperature. Is that like when the molecules travel at the speed of light, and there's like an absolute 0 degree where the molecules stop.
Mm-hmm.
I think as for measurement, we have Celsius, Kelvin, and Fahrenheit, and 0 K is like where molecules stop.
Let's talk about these units first, because for us to understand, in the United States, we all use the Fahrenheit.
Mm-hmm.
You guys know how they came to be?
No.
What is 0 Fahrenheit? What is like? How did they come to call that Fahrenheit even Fahrenheit? It's the name of a person.
Of a person that came up with the scale.
Fahrenheit. Do you know how it came up with it?
I do not. They like to be different here.
He just wanted to be different.
Yeah. So, any idea, Amanda?
No.
So, he took the coldest thing he can use in his time, which was a combination of ice and salt, and he took actually human temperature as 100, the coldest thing he could produce, the 0, and divided it in 100. That's why human temperature is close to 100, because he wasn't accurate.
Mm-hmm.
That's why human temperature is actually not 100, but 97 point something Fahrenheit. And the coldest thing he could produce, he called it 0, which was the temperature of that salt. Interesting part is that few years later, they could achieve lower temperature. So that was not a good thing.
Sure.
Yeah, because we know here in Minnesota, temperatures get way below 0.
Yes, but in his lab in England, that was the lowest temperature he could achieve. So now Celsius, where that come from?
I think 0 degrees Celsius is where like water becomes ice, and 100 degrees when it boils at certain air pressure.
But the name of Celsius, where does that?
No.
Another person.
No.
Yeah.
Yes,
Another
a
person?
Swedish person, a Swedish
Swedish.
person. That he actually, what he did, this is interesting now. He took the temperature ice or water freezes as 100, and the temperature of water boils at 0, and then graduated in 100. Few years later, actually about 10 years later, they said, that's nonsense. Let's swap it, go the other way.
Mm.
And the idea was he was a scientist. He made it in a way that it can be repeated, like it has to be at the pressure of the at 1 atmospheric pressure, sea level, has to be certain humidity and so on, because all of those actually affect those measurements. But if you follow his like a cookbook, if you follow his routine, you can measure and practically adjust your thermometer to those things at any point and anywhere in the world. So he came with a consistent way of adjusting, but it can be repeated. And nature really doesn't care where you take it 0, so on, or does it? Does. Nature does care about, there is, as Misha was saying, there is an absolute 0. And you said the name of that.
I don't know.
Absolute 0. What is absolute 0?
Like when the molecules stop moving?
Yeah, but what is that scale? What is it called when you call that?
0 Kelvin?
Kelvin.
What's that in Celsius? -3.
273.5.
Okay.
Something like that. But where does the name Kelvin?
Another scientist, I guess.
Another British
No
guy.
way.
Yes.
What?
So that is how you can get eternal, in science. Invent something.
I think we should invent a temperature scale.
Yeah,
you should-
Our own
Yeah,
temperature
You
scale.
invent the temperature for the social media kind of thing, the temperature, how you feel comfortable with somebody or not.
Yeah, I
Sure.
mean, like kind of similar to
Amanda
reading people's
Alyssa.
vibes.
Amanda Alyssa scale.
Yeah.
Well, I mean,
Double A.
I
Double
think
A,
I think
double A.
back to when I was a child, we used words like temperature for like games like hide and seek. When you get closer,
Yeah.
you said, "Oh, you're getting hotter, you're getting hotter," and when you get farther away, we said you're
Yeah.
getting colder. And it was that same concept of temperature, but we applied it to
Something
more
else.
real life
Yeah.
situations or ways that as children you can understand.
What is the absolute 0 in that temperature? You're
Well,
lost.
the second you touch the object that you're going with that's
Yeah.
on fire, you essentially it go back to there's
It's
no
100,
temp. There's that's the 100 on
Yeah.
the scale.
Amanda, I think where you would be good at
0, you're
using
When
the
you give
temperature
up.
when you go to a club with your friends, that you put like, you can assign the double A temperature scale to people in the club.
Yeah, like the likelihood of them dancing or getting a drink. What do you?
sure.
No, well, what do you guys, the young people use this, the hotness of person, the word hotness, somebody being
Yeah.
very hot. But
Or
you never use
attractive.
Or
something,
cool, like when
Cool.
someone's really nice, they're cool.
how comes
Let's
that?
Or
let's
hot-headed.
think back to even the color wheel. We were just talking about
Yeah.
that. That's split into colors as well based on cool tones, warm tones.
So let's go back because you're getting close to the quantum physics by color and the temperature. Now, let's go back to Kelvin. Did you know that the Kelvin really didn't invent the Kelvin, but it was a mathematical, physical calculation? Because there is something, everything in universe emits some kind of electromagnetic wave. Like you get a camera, thermal camera, can measure what our temperature is. That, as a matter of fact, these days when you go to a hospital, have a thermal camera, they see if you have fever or not. Many airports, they have these thermal cameras that just based on the wavelengths of what you emit of your body, you can measure if you have fever or not. So, and that temperature is that the wavelengths that you emit has everything to do with what temperature. And as a matter of fact, when you get at certain temperatures, like metal, you know that the metal can be red, can be white when it's heated up.
Mm-hmm.
That temperature, that the light wavelengths that it emits has all to do with what temperature they are. Like, did you know that when you, for example, when you melt lead, it never comes visible in your eyes. Like, it doesn't glow. And the aluminum, which is about 600 degree melting temperature, doesn't really glow either. But iron or copper or other metal, before they melt, they become really emit light. They become really bright.
Mm-hmm.
Have you noticed that?
Mm-hmm.
Yeah.
So what that has to do, all of that, is that, as you said, temperature, as Richard Feynman said, is just the speed of the molecule in anything bumping to it. People don't know there is no way this molecule, they don't bump or they don't. We can go very close to absolute zero, where theoretically molecules don't move. We can never ever achieve that. It's almost like a speed of light. On both ends, we cannot achieve that situation that the molecules don't move. But when we get close to that temperature, absolute zero, which for a long time, for 200 years, it was just a theoretical thing. But they calculated that when we get close to that, we achieve magical word. And that magical word, no, you get the chocolate bar if you tell me what the name of that magical word is. Called Bose-Einstein condensate. So, what are the matter? What are the status of the matter? We have gas, we have liquid, we have solid. There are two other.
Plasma.
Plasma is when you knock out all the electron of an atom, and it's just the atom without the electron. That's plasma. Yes. And the fifth state of matter is Bose-Einstein condensate. Imagine they cool us, all of us in this room, close to 1 or 3 millionths of Kelvin, at the lowest we have. Coldest place in the universe, in a lab, hasn't been outside of the planet. The closest we have come to the absolute zero, it has been there. But when you get that close, absolute zero, they would cool us, all of us, absolute zero. All four of us would become one single atom. Matter behaves in a magical, unimaginable way that we don't really understand. Like, friction completely goes away. Like, a certain thing happens that practically this is quantum physics, that every atom, the wavelengths, how it's behaved, it defines how it's behaved. They all become one, zero. You become undistinguishable, all four of us. We cannot wrap our head around that.
No, I'm trying to wrap my head around, like, what would that process look like? Would we slowly start becoming closer?
So I can tell you how the atom, because that they achieved that for something like 300 atom of helium. That's how they achieved that. But they haven't ever done it with the macroscopic things. It's just not possible. They have done with helium, those, like, what the 0.1 hundredths of the absolute zero. Like, when they cool down helium to that temperature, actually start going against the gravity. Those friction completely goes away. Just practically it just goes around along that vessel that it contains it, and it goes through the vessel. It just behaves in a way that you don't really know how it's behaving. But they have been able to achieve few hundreds of atoms of helium cool it that down, then the individual atom become irrelevant. They don't really exist as an individual atom. Meaning that the motion of those individual atoms define, which is nothing unusual because we knew that from 100 years ago, research and theoretical years ago, that the motion of any object is actually its temperature. Like something that is water molecules are 100 degrees, the molecules, they hit each other faster. That is what they evaporate. Because one of those molecules hit another one on the surface and bump it in the air. So that is actually what temperature. Now, and we went all the way to bottom part, what the temperature. So let's go to the highest possible. We talked about that the higher temperature change the electromagnetic wave that you, and all of that. What that means, the frequency of the emitted light goes higher. Like the frequencies that we see, our eyes are see, practically the rainbow goes from red to blue, right? Then violet, and then ultraviolet, and infrared. Now, you would be surprised. Like everybody thinks that the red is warmer, and you would think red has more energy. Just the opposite.
I remember learning about that in school about the colors
did
of
you
the
learn?
stars. That when you're looking at fire, blue and white are actually hotter than red
Hotter.
and yellow.
But why do you, when you are in a closer to a blue color and closer to a red color, why a red feels warmer to us? Because it has less energy, so we can absorb it. It moves slower. If something moves too fast, you cannot absorb it, so you don't feel the warmth of it. But red has less energy, so our body can capture those photons, so we feel our skin warmth of the red glowing iron, whereas true blue, the energy is too far, our body just cannot absorb it. Blue violet has more energy. What does that mean? Higher frequency, if it goes up and down faster, it has more energy. If you go higher than ultraviolet, what do we get? X-rays. X-rays that we are shooting in the other room is electromagnetic wave that it moves so fast, our body can just not deal with it. It does just go through us. But our bones absorb more of it, and the soft tissue. So on the background, we can see where is the bone, where is not bone. What happens if you go even higher energy? Gamma rays, where practically comes from radioactive material or stars and so on, are so strong they just go through us. Once in a while, very little of it can just break our DNA, that the radiation exposure, that the danger of radiation exposure. But considering that this goes, it's a waveform that goes up and down, there is a limit to that. Because when it goes up and down so far, what is you might not be familiar with that, but radio waves are on the other side. You have infrared, and then when it comes much lower, like your cell phone and radio and TV, they all work with radio waves they have the lower frequency, and but if there's a frequency lower, the wavelength becomes inverse related. So too much science, we will move out of science pretty soon. But you need to know that the radio frequency on the lower area where we see, and the X-ray and gamma is on the higher. There is the absolute maximum to that on both ends. We are lucky. We live in an environment that those temperatures that we deal with are within freezing and boiling. Actually, not even within the life happens most of the time in 0 and 100, but
Celsius or Fahrenheit?
Oh, let's talk about Celsius. In science, nobody
Well,
uses
because we're in the
Fahrenheit.
U.S., so when you're talking to us, we're gonna automatically think
Yeah.
Fahrenheit.
Yeah, well, let's say in science, we talked
Well,
about
Us.
Us.
It's not him.
So,
Celsius as
we
well.
talked
Yes,
about now.
of
Let's come
course.
to what's interesting for you. What does that mean?
Well, we only have 1 minute, so I think we should save that for our next.
The next
Podcast.
segment.
No, I want to just take 2 minutes to say.
I want to go more in depth though about.
Yeah, we will. But higher temperature, meaning molecules are moving faster. What that means, any chemical reaction happens faster. Lower temperature, molecules are moving slower, chemical reaction happens. Why do we have fever? Because our body wants to have faster reaction to fight infection. If when we have fever, higher temperature, our body is trying to reset our value of so chemical reaction, how our body fights the infection, come fast. We will come back to that. But we have this phrase, somebody caught a cold or catching a cold. Okay? Now, when you are in a cold environment, or your body, your molecular biochemical activity in your body is lower, so guess what? If your body and your immune or all your biochemical things are lower, you cannot fight some agent efficient enough. So truly, that has an effect on if like a bacteria or mostly viruses can get where they need to go to be causing a problem. What do viruses want? They want to get into your cell and replicate.
Mm-hmm.
And your immune system is just waiting there, want to fight them. So if you're in a cold environment, all the immune reaction, all the biochemical reactions are colder, lower, and mostly in your respiratory. That's how we can. If all your mucosa and so on are colder, and not fight it efficiently, the viruses can penetrate easier. So hopefully that answers your question.
So cold temperatures make you more likely to get sick, but they don't get you sick.
Well, it makes it more likely for the virus to go through your mucosa and your respiratory tract and get where they want to go. And it makes it less likely for your immune system to effectively fighting them. For the same reason, your immune system reset your temperature higher when they know there's something bad is going to increase the biochemical activity that would be responsible.
And that's why you get the fever.
Fever is your body trying to fight the infection. Fever is a biochemical, it has some side effect. You feel not good, which is good for you because then you rest and your body can fight the disease. And but fever is a biologic reaction. Okay, well, I did most of the talking. So
Well, you have most of the knowledge.
So, any question? I think we should answer. Each of you should ask a question, and
So I just want to clarify.
Yeah.
Cold temperatures don't produce bacteria and don't produce the viruses, but they just weaken. So then you're more.
I say it creates a susceptibility.
Yeah.
correct.
My question, I guess, would be like, why are virus or bacteria why aren't they susceptible to temperature?
That is an excellent question. And to answer that question, I'm going to tell you something. Why is fish? Why fish goes bad so much faster
I
than
know
beef?
this. We know this one.
I forgot.
What?
Like the water, and because they were used to the colder temperature, and if you bring them to room temperature,
All
they
bacteria
spoil.
and viruses are different, but our bodies used to live at our temperature. Like beef has almost our temperature. Fish in water has lower temperature. Bacteria in fish are used to that. They're maximum. They're optimized for that temperature. Now you bring a fish to a room temperature. Those bacteria say, "Wow, you're faster." So a 3-day fish goes bad much faster than a 3-day-old beef or pork, because when you put a beef in room temperature, it's actually you're lowering the temperature, whereas when you put the fish
Fish.
in room temperature, you're increasing the temperature. Now, what temperature do viruses?
I don't know.
The optimum, you're
You
in a
know.
you're in a
Room
Yeah.
temperature.
no, well, they're in an
Any
environment, any temperature. So, but what that means for them, when you lower your temperature, you are at the temperature that the virus is at optimum, not your body. When you are breathing cold air, cold dry air, you are drying your mucosas. You're reducing your capacity to fight them, whereas for them is their usual temperature where they are at. So it is like letting two team play, but you handcuff one of the team. The other team has an advantage. Okay,
Okay.
lots of nerdy stuff. I hope a few people learned something here.
I did.
I did.
Okay, well, thank you very much for joining us for Essence of Science, what's temperature, and why we get sick from the cold. I'm
Thanks.
Dr. Bossi.
Amanda Armagost.
I'm Melissa Haber.
Misha, thank you for joining us.
Thanks,
Thank you.
guys.
Thanks, guys.